Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. Today's practice problem is going to be a student sorter. Given an array of student objects where each object has a name and a GPA, implement a selection sort by GPA ascending, and we'll print our array out before and after sorting. Before we jump into the code, let's just take a look at an example here. If you don't remember how selection sort works, we're just going to walk through an iteration or two of the algorithm. Here, we're going to have two different markers. We have our next sorted position being 0 right now, and our search position being 0. And the algorithm is as follows. We're going to find the minimum value between I being the next sorted position, so in this case 0, all the way to the end. Once we find that minimum value, we'll swap it with our next sorted position, we'll move to the next sorted position, and then we will repeat this algorithm. We will continue to do this until there are no more next sorted positions to traverse. So let's take a look here. We're going to find that minimum value between I equals, in this case, 0 and end. So as you can see, I've tried to color code my I so that it's clearly representative of all three of these right now. So all three are pointing to index 0. And then what we're going to do is we're going to slowly move through our array. So I becomes 1, while the next sorted position and the minimum value are both still at 0. The comparison happens here between the value 5 and 2. We recognize that 2 is smaller, and so our minimum value position does move to 1 now. We can see that the color has shifted. So the next sorted position stays over here, while the min value position and I index have both updated to 1. And we continue going through. We compare 2 and 18, and we see min value position should not update. Comparing 2 and 4, comparing 2 and 11, and finally comparing 2 and 1, finding a new minimum value position. Once we've now reached the end of our array, so I went from the original next sorted position all the way to the end, we can now swap our minimum value into that next sorted position index. So these two values will swap. We can now see that we have a sorted value here. We have found the minimum value in the entire array. We put it in the very first position. And now all of our values update. The next sorted position that we need to use is going to be 1. So that's over here with value 2 internal to index 1. And now when our I goes from next sorted position to the end, it will actually start at 1. And our new min value position also starts at 1. What will happen is, again, we'll go through our entire array until our I reaches the end, having found the minimum value to be still at this original position. It will kind of like, air quotes, swap with itself and allow us to move forward. Now, same thing, you'll see we have two sorted positions. The next sorted position moved to the next index, index being 2. I will now go from 2 all the way to the end of the array. And when we do that, we'll end up finding that the new minimum value in this portion of the array is found at position 3. So that swap will now occur. And again, we have a sorted array. We will now perform that exact same find minimum on this small portion here, finding it in that final value. The swap will occur. And then these last two values already in place will still run the algorithm, but we end up just swapping with ourselves both times, and we end up with a sorted array. And now our next position will have incremented to the length of the array, meaning we have no more next sorted positions to work through, and our array should be sorted. This is only one of a few algorithms that you're going to learn about sorting through numbers or data points. So I'm not going to have videos on all of them, but this is the worked solution for the selection sort. Now, to get started, I've already created my student class with my string name and my double GPA. You'll notice I have my constructor. You'll also notice I don't have any getters or setters because I don't need them, and I want to keep that data as private as I can for as long as I can. Now, for this specific example, we're talking about sorting by GPA. So I've got right here this compare GPA that will bring in a student other, and we'll compare the two values, this dot GPA minus the other. So what that means is, I'll put in a little comment here, if this GPA is greater than the other GPA, other dot GPA, this is going to return a positive value, just because that's how numbers work. If this GPA is the same as the other GPA, this will return 0. And if this GPA is less than the other GPA, this should return a negative number. And that's the information we're going to use in order to determine our minimum value. Now, if you wanted this to behave a bit more the way that a string.compareTo behaves, there actually is a very clean way to do it. It's right here. You would just have your public int compareTo or compareGPA. We can call it a compareTo. And we can actually use something called double.compare, because double.compare will actually return an int, which is what the string.compareTo also returns. So I thought I would just include that. I'm actually not going to use it, but I thought it might be nice to see. And then of course I have my two strings so that I'm able to actually print out my information. Now I've also put together a main method already where I've created a student array with a bunch of students in it with varying GPAs. And I've got my little before sorting print going on here. Now I've never used the arrays.toString before. Normally I just write my own method, but I thought, why not? Here's a good opportunity to show you how that works. Now I'm going to do a compile star.java since I have two Java files I need to compile. Oh, and I forgot, calling this actually requires me to bring in an import statement. So let's go ahead and do exactly that. Import java.util.array. There we go. And let's recompile, make sure that that now works. Perfect, it does. I'll clear this out of the way and I will run my main just so that we can see I'm getting that output right now. Alice 3.2, Kwame 2.8, Shaheen 3.9, Connor 3.2, and then Mustafa 4.0. So we can see now how we're going to go about wanting to reorder our data points here. Let's go ahead and write our selection sort algorithm. So selection sort will take in my students array, and then I will go ahead and just copy paste these right down here and do an after sorting. For what it's worth, because I did do a copy paste, really good practice would now have me create a method like a public static void print method that will take in my student array, and I'm also going to have it take in a string title message. The reason why I'm doing this is because I can now pick up these two lines and put them right here, where first I print my title message and then I print my student array, just like this. And now these two lines can actually become a single print, like this, with passing in students and passing in my title message. There we go. Clean this up. And I can also do that similarly right here with my after sorting print message. So this just kind of cleans up my main method a little bit. It's not quite as responsible for so many things. And if I want to get really clean with my main method, I would also make a method here, student create my array. And I would pick up all of this. This would call create array. And all of this would come into here. And I would return this all like this. So now my main method is just responsible for driving the program. It's not actually doing any of the work. Now that I've got that nice and organized, I can go ahead and write my public static void selection sort. And all we're taking in is that array of students. Now we can go and look again at what that algorithm was. But I am just going to write it out because I do remember it, thankfully. For each next sorted position, we want to look at I equals the next sorted position all the way up to the end of students. And what we're trying to do is, I guess I'll put it up here, to find min value. If that I guess students at I is smaller than whatever our current min value is, if it is, we will make our new min value equal to I. So we're going to keep track of that index. And then once we reach the end of our array, we need to swap min val into that next sorted position. So this is basically what I have pulled in from my slide, my little slide set there, but hopefully we can sort of walk through this on our own as well. Let's just get started by writing this swap method, because swap is usually pretty easy for us to write. And it's its own function most of the time. So a public static void swap function will take in the array that we're working with. It will take in the position that we are swap to and swap from. And with arrays, it's really easy, especially with references. It's just really, really quick to do this swap, actually. So we're going to make a temporary variable, and we will grab whatever is in swap to so that we don't lose that reference. Then we'll go ahead and we will go into that swap to index and move whatever is in swap from. Finally, we can take our temp variable reference students and place that value into swap from. And since it's all references, it's all shallow copies, no return needed, this will do our swap for us. So now once we're ready, we'll be able to use that swap function right there. Since we're going to do a for each in the next sorted position between 0 and the end of the array, and we need to look at I from next sorted to the end, that tells me we need two different loops. So for int next sorted position starting at 0, and we want to go all the way to the end of our array, so all the way to, next sorted position is less than students.length. We're also going to go up by 1 each time. So that is our outer for loop right there. We'll put this like that. Now we told ourselves that we're going to look at, for I is equal to the next sorted position to the end. So let's grab I, start it at next sorted position, and go up to the end of our array. And what we're trying to do is find the minimum value. Now, if you recall from my little slide set, we're always going to start that min index, int min val index, at I. And I always starts at the next sorted position. Whoops. So we can grab the next sorted position and know that that is always our min value index that we want to start at. Now we can walk through and we can ask ourselves, if students at our current I position is less than students at our min val index position, what do we want to do? We want to keep track of that min val index equals to I. Once we've finished running through all of this code, which is not correct yet, I'll fix it in a minute. There we go. Once we have finished that, we've found our minimum value index, we found our next sorted, we can call our swap on our students array where we want to go swapping into the next sorted position, and we're going to grab wherever our minimum value index was. Okay, now this code looks like it would work. The main concern, if you haven't caught it yet, is that we can't use a less than for complex objects. Less than doesn't make any sense here because we're talking about student objects that have lots of pieces of data. This is where that method that we wrote needs to come in here. So we understand that we want to do a swap if the GPA that we're looking at here is less than the GPA that we're looking at here. That is going to be this scenario right here, which, as I wrote, means when this compareGPA returns a negative value, we need to do a swap. So what we actually need to do here is call our .compareGPA method. And now if this returns, we'll go right here, a negative, we need to do our swap. We can now see that this actually will indeed compare not the object references, but the internal GPA value itself and find our minimum index. Once that's completed, we do our swap and come back up to the top only to run this again. Let's see if this code runs as we'd expect it to. I'll clear this out, I'll recompile, make sure I don't have any missing values. Of course I do. Let's find this, Java 50. Open this back up. Oh, we just accidentally didn't pull that in correctly. Oh, and now I have all these spelling errors. Main Java 34, students spelled like that, and main Java 35. This should have been the word temp. Thank goodness for compile time checking. Java compiles, no problem. Let's go ahead and run our code. Here's our original before sorted array as we expected, and a reminder, we're looking to sort in ascending order, so smallest value to largest. What we'll see has happened is Kwame swapped with Alice. Alice and Connor did not change even though they have the same value, because this compare only will make a note of a minimum value changing on a less than 0. Then Shaheen at 3.9 and Mustafa stayed in his same position because of 4.0. So our selection sort works. It's worth noting that if I did say compare GPA less than or equal to 0, Connor and Alice would actually switch positions, because when they got compared, Connor would have become the new minimum. So just to show you what I mean, rerun, we can see that while the actual answer is still correct because they were both 3.2, Connor and Alice did swap positions unnecessarily, but still correctly. It's worth noting because there is then a functional difference between the less than and the less than equal, even though technically they both give us the right answer. So that's just something that it's worth noting and understanding why that very small change did result in a different after sorting array, especially if you are working on this in a problem space where maybe there are automated tests and you're getting the wrong answer. And it could be something as simple as a less than or equals versus a less than, because even though when you look at your answer, it looks correct, some kind of output checker might be looking for something different. That's it. And now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.